Uh, so Dr. Devdatta, they are starting. Okay. So Dr. Monin, you can start. Okay.
Okay. So very good evening to all the sir and ma'am present over here. Now in today's class, we will learn some more advanced technique in QGIS environment. But before going to the advanced steps, I would like to recap the previous session. So, sir, if you have any doubts from previous session, you can tell me. Then we will proceed further. Sir, is it audible?
Yes, it is audible.
So, if you have, sir, any doubt from the previous session, you can tell me. I will clarify, and then again we will proceed to the next session.
Sir, I have some doubts.
Okay.
Sir, actually, I am facing problem in transferring the georeferencing. It is saying that there is some problems in output, means the output file. So how to
Okay.
rectify it?
I think, ma'am, there might be some problem when you doing the process. So today we now just again we repeat the process of georeferencing. So first you have to import your data set. So in today's class, I will use another data set of Hooghly district. So first you have to import the data sets that you want to georeference. So from the raster button, you easily import the data set that you want to georeference, or from this layer also go to the layer menu and then go to
Could you please share the new data set as well, the new map? Or
yeah. I'm sharing the data set in the WhatsApp.
Okay, thank you.
Yeah, I have shared it. So first of all, we have to import the data set by using this layer menu. From this layer menu, you have to go to the add layer option. And then from this add layer option, you can add the raster layer. As I think all of you have quite ideas what is raster dataset or raster layer. So raster dataset is nothing but it is the arrangement of rows and columns, and a set of pixels are there. And for each pixels, you may have different distinct values. Okay, so it may be a images, it may be a photographs, it may be a scanned map. So all these data sets, we called it raster data. So just we import the raster data from our computer drive. Yeah, so our raster data set is located over here, base map. And for today's session, I will use this particular data set, Hooghly district. Then click it open and add it. So now it will added to your QGIS environment. And again, I will repeat the whole process of the previous session. How do I georeference a particular map? Okay. So to do that, again, I have to go to the raster layer first. And under raster layer, there is an option called georeferencer. If it is not coming in your system, then you just make a click on the open space of your QGIS interface, and then so many options are visible to you. So you just have to click on the layer panel, and you also have to the digitizing toolbar. So check the layer panels and digitizing toolbar. In addition to that, you just go to the layer panel, and then under layer panel, you go to not the layer panel, actually this is a view panel. So go to the view panel, and under this view option, go to the panel. Again, in this panel, whenever you are clicking on the panel, then several options are showing to you. So just click on the layer panel, and I think it will be visible to you in the under raster options. Georeferencer toolbar are available. So just go to the georeferencer toolbar. Again, you have to import the map that you want to georeference. So Hooghly district, add it. Now the map is being added to your QGIS georeferencer dialog box. Now you have to add some input points so that you align this map to the actual surface of the ground. So you have to provide 4 input points, as I have already mentioned, 3 for georeferencing process and 1 for your accuracy assessment. And it depends on the transformation type you are using. On that particular basis, you have to select the number of points. If you are using the transformation type polynomial 1, then you must have to use 4 points. If you use polynomial 2, then the number of points you have to provide the input is bit larger. Okay, so for today's session, we will just use polynomial 1, and for polynomial 1, we just have to provide 4 inputs as a coordinates. Okay, so transformation type is polynomial, resampling method should be nearest neighbor, and then target SRS. So that means SRS means spatial reference system. Okay, spatial reference system is a framework of coordinate system, and it can be divided into 2 sets. One is geographic coordinate system, another one is projected coordinate system. So first of all, whenever we process a map or whenever we georeference a particular map, first we use the GCS or geographic coordinate system, which is actually based on the 3-dimensional spherical model of the Earth, whereas projected coordinate system is based on the flat surface or 2-dimensional model of the Earth. So first we have used the GCS as our spatial reference system, and in this particular case, our GCS is EPSG 4326 WGS84. So EPSG, the full form of EPSG is European Petroleum Survey Group. This European Petroleum Survey Group assigned different values to different coordinate system. But for globally, if you want your map should be accepted globally, then you have to use this particular GCS or geographic coordinate system, that EPSG 4326 WGS84. Okay, there are several other options are also available. If it is not appear over here, then you just click on this particular globe, and another dialog box will open, and you make a search over here, that WGS84, and it will appear to this particular window. Then click on that particular GCS coordinate system, WGS84 EPSG 4326, and click on OK. Now you have to save your output raster to a specific folder. So to do that, you have to go to the folder in which your dataset is located, or you may save it in another folder. So for this particular session, I will save it in another folder called georef. So in this particular folder, I will save my output, and you have to provide a name for this particular georeferenced output. So I will named it as georef and the district name, that means Hooghly. Now save it and then click on OK. The remaining things, you need not to change anything, just click on OK. Now you have to provide 4 input points from anywhere of the map, but the point is you have to provide the inputs from different parts of the map so that the map should exactly aligned with the surface of the earth. So now I will provide the input points. So first I will take this point, and the value of this point is, you may see that the latitudinal value is 23 degree 10 minutes and longitudinal value is 87 degree 30 minutes. Okay, so I will provide the input. Yeah. X should be 87 30 00 and Y should be 23 10 and 00. And this is the projection system, GCS coordinate system. Now click on OK. So I have given my first point as an input. Now I will provide the second point as an input. So to move the map, you may use this pan button. Now click on here. I will take this point as my second point. So the value of the second point is latitudinal value 23 degree 10 minutes. And again, longitudinal value is 88 degree 30 minutes. So provide this as your input. Longitudinal 88 degree 30 00 and latitudinal values 23 10 00. Then click on OK. Now in the same way, you have to provide the input for third points. So I will take this point as my third point. So for this point, the value is 22 degree 40 minute north and 88 degree 30 minute east. Okay. (22 degree 30 minutes and 00). Easting is 88 degree 30 minute and 00. Now I have provided 3 points. Again, I will have to provide another more points. So I will take this point as my fourth point. So 22 degree 40 minute north and 87 degree 30 minute east. Okay. (87 30 00) and for Y 23 40. Yeah. 40 0 0. Now click on.
Sir, we can choose any point of our choice, or we
Yeah, you
or
can
the
you
four
can
points
choose.
are equally spaced.
No, actually you can choose any point. Actually this point actually I have make a mistake for, and that's why this error is coming. So I will delete this particular point. And for deleting a particular point, you just go to the edit option and delete it from here and make a click on here. So our third point is now getting deleted. Okay. So again, I will provide input for this particular point. So it is 22 degree, 40 minute north, and 87 degree, 30 minute east. Okay. So 87, 30, 0, 0 and 22, 40, 0, 0. And this is the actually why this error is coming. Yeah. Again, I will deleting this point. The error is coming for this point only. $87.30.
So where can we check what entries we have made for each point?
Yes.
Is there a table where we can check what values we have put for each data point? Because what I see in the GCP table, I don't see the coordinates here. Or are these the coordinates? Destination X, dest X, and dest Y?
Yeah,
These are actually
actually,
the coordinates. These are actually the coordinates, destination X and Y.
Okay.
So X value is 87, 30, 0, 0, and Y value is 22, 40, 0, 0.
Manuel,
Yes, sir.
check the third one.
Okay, sir.
Third one, don't need to delete it. You just go to the GCP table and change it.
Yeah. 88 and 22, 5. $88 50. Why it is coming 50?
Change it. Go to the GCP table, change it.
$88 30 30. Again 87 30.
Amma,
Why this error is coming? Sir, I'm repeating the process again. I think there might be some problem while I'm providing the inputs. Okay. Twenty-three ten. Eighty-eight ten. 23 10. Twenty-two core. 88 10. 88 10.
Sir, sorry to interrupt, sir. Yesterday you told that the points should not be collinear.
The points are not collinear.
Okay. Sure.
Actually, 2 points can match, but more than 2 points cannot match.
Okay, more than two
Yeah,
points should not be
yeah, yeah,
collinear.
yeah.
Okay, thank you, sir.
Now I will take the last point 2240, 23 10. 2240, 87 30. Then 87 40 0 22 40. Yeah. Now this one is accurate. I think in the previous time there might be some error. So that's why this residual values is coming a big number. But now in this particular case, the residual values are less than 1. So now I will proceed to georeferencer toolbar and start georeferencing.
What is the importance of that residual value, sir?
Yeah.
If the residual values are, see here it is point something now. So if it is say 1 or something like that, so it is 1 pixel. 1 unit represent 1 pixel. 4 units represent 4 pixels. 10 units represent 10 pixels. So it should be minimum. It is statistical residual.
Okay, sir. Thank you.
Okay.
Yeah. Now our georeferencing has been completed. So if you want to save the GCPs, you may save it from here. Go to file and then save the GCP points. Okay. So you may save the GCP values as well. So now if I uncheck this particular original map and click on this particular georeference map and zoom to layer, then the georeference map is now visible to you. And here the coordinate is showing coordinate 87. If I move the cursor on the map, then the coordinates is showing. Okay. So our georeferencing part is now getting completed. So the next part is we have to
Manoj,
reproject
just
it.
interrupting you. Have you
Yes,
told
sir.
about the SRS?
Yes, sir. I have told a bit.
Okay.
So now this particular map is in the geographic coordinate system, as I have provided the input SRS as EPSG 4326 WGS84. Now I have to convert this geographic coordinate system to projected coordinate system or PCS. To reproject this map, again we have to go to the raster, and then from this raster go to the projection option. From this projection option, you have to click on reproject. Then you have to provide some parameters like input layer. So our input layer should be Hooghly district modified. Yeah, so this is our input layer. Source CRS. So the actual CRS that we have used at the time of georeferencing, and this is EPSG 4326 WGS84. That means this is the GCS or geographic coordinate system that we have used at the time of georeferencing. And now you have to provide the target CRS on which you want to transform your GCS to PCS. So target CRS is your EPSG 32645. And how do we from where do you get? You just make a click on this particular globe, go here and make search WGS 84 slash you may find it from here, WGS 84 UTM. Yeah. So here these different UTM zone are showing. So you have to select for this particular study area, the UTM zone is WGS 84 slash UTM zone 45 north. So you have to select WGS 84 UTM zone 45 north, this particular, and the value of EPSG for this particular case is 32,645. Just select it and make a click on OK. So this is our target CRS or projected coordinate system, and this is the GCS or geographic coordinate system. Now you need not to change anything, just provide the folder or location on which you want to save your reprojected file. So just go to this particular reprojected save to temporary file, and then save to file as, provide the output location. So in this particular case, I will provide my output location as georef and georef underscore reproject. Yeah. Save it. And now you click on run. So now our reproject process is being completed. So this is the actual reproject image and the reproject map, and this map is map unit for this particular map is meter. But in the previous case, when we use the GCS, our map unit should be in degree, minute and second. But actually you see that here again the coordinate is showing in decimal values, because in QGIS the interface record the previous one. So if you remove the map from this QGIS interface, discard all the maps, and now again you have to open. If you open georef reproject map, add it, and now see this value actually is in meter. Okay, So in the previous case, it was showing in degree decimals, but actually in reproject case, this value is showing is in meter. So our reprojection is also completed. Now we have to proceed in the next module, that is the digitization process. So
Sir,
still if you have, yes.
sir, the target series and source series, there in the bracket there was written was optional. So we need to fill up this series or we
Yes,
make it
yes.
blank.
Yes, you have to provide the input CRS or target CRS. Otherwise, it will not be reproject your image.
But
You
it
have to
was
provide it.
optional. That's why I asked.
How do we get to know the exact projection? Like, which is the projection that we want? I mean, how to set it? Like,
For if you
Okay, Manu,
want,
let me show them something. Okay. I'm sharing my screen. There. Okay, ma'am. The fact is, it visible? My screen is visible.
yes, sir.
Okay. So the previous day, what I was saying is that whenever we actually look at anything on the surface of the map, so we need three coordinates. One is the latitude, the another is the longitude, and the third one is the datum. And what is this datum? You have lots of datum throughout the world, lots of datum. For that, you need to be a very good, a very good surveyor or a geographer to understand which is the datum that I should give. But basically, I will like to give you the fundamental understanding of it. See, if this is considered, I have shown you this picture the last day. If this is considered as the curvature of the earth, say from this red line, this one. So if this is considered as the curvature of the earth, now consider anybody residing in the northern area, say for example, Greenland, Iceland. So when they will be doing this kind of a survey, they'll be doing this kind of survey, they'll be getting a flattened area. While anybody residing near the equator, they'll be getting an area where the curvature is quite high. Okay. Say for example, if I take this particular experiment, I name it as walk experiment. Say, let's consider this one as the equator. This X, what is marked as X, it is the equator. And let's consider this to be 1 degree. That means having an angle of 1 degree from the equator, that is the latitude is 1 degree. And let this be 90 degrees. That is what we call as a prime meridian. And let this be 89 degrees. Okay. So let's understand the experiment. Say, for example, somebody is walking from this 0 degree to 1 degree, and somebody is walking from this 90 degree to 89 degree. So if the earth has been a perfect sphere, both of them would have walked the same linear stretch or the same linear distance. But what happened is that the earth is not a perfect sphere. There has been a polar flattening and there has been an equatorial bulging. All of you have read this in the class 6 or 7 geography books maybe. So due to that, what happens is that anybody making a survey over this area in the parts, maybe say if this is considered to be the 45-degree angle. So anybody making a survey over this area would be having an earth area like this, And anybody doing a survey in the area near to the equator may be having an earth area like this orange one, because they'll be having a higher curvature. Now, what is curvature? So mathematically, curvature is defined as the rate at which the curve curves. I'm repeating it. Mathematically, curvature is defined as the rate at which the curve curves. So basically, near the equator, the curvature is quite high, but whereas near the poles, the curvature is quite low. So depending on that, when there was a lack of technology and lack of communication, say if we say in before 1960s or before 1950s, when there was no internet, or even 1970s when there was no internet, so every country for locating their own map, has made a survey of their own, and they have created a surface of the earth which coincides with the area where they have surveyed. But after 1972, there was a World Geodetic Survey which was done, which is known as WGS 84, World Geodetic Survey. And it was rather modified in 1984, when it is known as the World Geodetic Survey 1984, that is WGS 84. So on the basis of that, we have created a mathematical algorithm which best fits the Earth's circle, the whole circle of the Earth. Okay. I don't know whether I am clear to you, but what I wanted to say that WGS 84 was Moinul selected just now is something which is the best fit mathematical algorithm, the best fit mathematical algorithm to create the datum of the Earth. Is it okay, madam?
Okay, sir. Thank you.
So it is a best fit mathematical algorithm. Now, depending on that, what we do is that we use an instrument, or we use a, I can say, instrument, you can say anything, or equipment. That is GPS. Everybody of us say about GPS. This GPS is nothing but this is a product of GNSS, or Global Network Navigation Satellite System. So what the GPS fetch? The GPS is actually the Global Navigation Satellite System of US. It's just like what to say, like just like a photocopy and Xerox. Most of the time we say we go to a shop and ask the shopkeeper to make a Xerox of it. But Xerox is it's not a mechanism. Xerox is the name of a company of US who used to make photocopies. So photocopy is basically the mechanism. Similarly, GPS is the name of the company, or the name of the product of US, of GNSS. So GNSS is basically a system, or Global Navigation Network System, satellite system, is such a system which fetch the data for the latitude, longitude, and the datum of a particular area. Okay. So for us, since we, while doing mapping, say you are doctors and you have been to a place, say for example, a disease X has been spreading in a particular area, and you have been visiting that particular area, and you wanted to find out that what are the reasons for the spread of that particular disease, and you take the GPS with you and you collect some data for that. You fetch the latitude, longitude, and the altitude for that, and you come back home, and you want to import that particular data into the georeferenced image. So therefore, the UTM WGS 84 is the most compatible platform, where you can transform all the data. Otherwise, if you please look back, if I am I mean explained, then I'll just like to ask Manul. Manul, please open that SRS.
Yes, sir.
Because there are lots of SRSs. I mean, lots of geographers can explain you the reasons for selecting a particular SRS. But beyond this subject, it will be difficult to gauge which one to understand. So it is better to take a platform which is more or less acceptable to, or compatible to, every equipments or softwares. Manu, share it.
Yes.
Bring it.
Sir, it is not possible to share 2% at a time.
No, I have stopped it. You shared it. You share your screen. You go to that SRS transformation or anywhere.
Yeah.
No, this one, you go to the browsing one. Browse it.
Okay.
Yeah, see the coordinate reference system, and Manul just coordinate reference system. You just browse it. You go on browsing. See how many SRSs are there. Lots of SRSs are there. See, see. So there are lots of SRSs. It will be quite difficult for any non-geographer to understand which SRS to select it, because projection is a subject altogether. If we need to understand which SRS to select very particularly for an area, it will be a 1-year course. So it's better to go for a platform which is compatible for your instruments. It is better to go for a platform which will be compatible for importing and exporting data. Okay, Manuel, stop it. So but there are lots of SRSs. Okay, so it's better to go for an SRS which is known as WGS 84. It's a compatible geographic coordinate system with UTM, which is actually a projection, and Zone 45. Zone 45 will be working in areas of West Bengal, Bihar. In North India, it will be zone 46 north, and in South India, it will be 44 north. Okay. So I will provide you the data for India, which part to select. Which part to select. For India, I will provide you the data. I mean,
Okay, sir. Thank
I
you.
hope that we are working with Indian doctors, so I can provide you the data with for India, the parts of India. Say for you belong from the state of Tamil Nadu, and you want to do an experiment in the from the state of Tamil Nadu by recording your data, or say somebody is from the state of Haryana, and he want to perform an experiment with the data from Haryana. So I will provide you the data which will fit best for the UTM projection. So go for WGS UTM projection zone. I will provide you through WhatsApp.
Okay, sir. Thank you.
Also
Okay.
for Sri India map and Maharashtra.
Okay, from Maharashtra also I will provide you. I'll provide for all the states. Okay. You have to know the latitude and longitude of your own place, and therefore you can fit it automatically. Automatically you can fit it. Manu, continue, please.
Yes, sir. So actually, I was going through the chat and someone is asking like why we are doing this. So the answer is actually we are doing georeferencing to align this particular map to the actual surface of the earth, and now we will create some information or data set by using this map or by digitizing this map. So as you already familiar with the concept of raster data, now there is another set of spatial data that is called vector data. So vector data is a type of spatial data which is consists of 3 geometrical features. One is point, another one is line, and third one is polygon. So to create a vector features or to create a vector data, you have to go to the again layer panel and then create layer option. And from this create layer option, you have to go to the new shapefile layer, and this kind of dialog box will open in front of you. Just select a file name. So in my particular folder, I will save the output in this particular folder, digitization folder. So you may create another folder and give a suitable name for this and provide a name over here that save file. Save it. Then select the geometry type. What type of geometry you want to create? There are 3 types of geometry that are available: point, line, and polygon. So you may create point features, you may create line features, and you may create polygon features. So first we will understand the polygon one. So I will select the polygon feature, and here again you have to assign the coordinate system. So here I will assign the projected coordinate system. Okay. So the projected CRS is EPSG 32645 WGS 84, and for this particular zone the UTM zone is 45 north. Okay. Now you have to provide a name for this particular field, and as I have selected the polygon, so polygon is basically a enclosed entity consists of multiple connected points, and provide a name for I will digitize the block. in this particular map. So I will name it block boundary. The type of data is the text data. Just add this block boundary field to this particular location and click on OK. So a shape file is now created. So this shape file we called vector file or vector data. And now from this, by using this shape file, we will create some data set, polygon data set. So just click on shape file. And when you click on shape file, a tool is now highlighted. So this tool we called toggle editing. So just make a click on toggle editing. And now again, these particular sets of tools are now highlighted. Click on this particular tool, add polygon feature, and start digitizing the particular blocks you want to digitize. So I will start from here. I will start digitizing. Yeah. So actually we are creating some data set. And to do this, georeferencing is the primary step you have to follow. Otherwise, you can't create a shape file. To up and down the map, just use the keyboard arrow, up and down arrow. And if you done some mistake while digitizing, just use the backspace. So now, this particular block I have digitized. To finish this digitization, just click on the right click on your mouse and provide a ID name and the name of the block. So this particular block name is Goghat 2 and click on OK. So now this particular block has been digitized. In the same way, you can digitize n number of blocks you want to study.
Sir, could you please repeat the steps for this one from the beginning? Because we are trying
Yes,
to do it
yes,
at the
sir.
same time, so it's hard to follow and look at the
Yes,
two
sir.
screens
Yes,
at the
sir.
same time.
Yes, sir. Yes, sir. I'm
So
repeating the process.
I just missed the beginning of it. Yeah.
Yes, sir. So I'm deleting it. Yeah. Just go to the layer panel or layer menu. From this layer menu, just click on create layer. And so many options are available to you, but just click on new shapefile layer because we are creating a vector feature or vector file, and the format for this vector feature is shapefile. .shp is the format. Now a dialog box will open. You just provide a name for the particular file you want to create. For the previous one, the file name was shapefile. So now for this particular one, I am just using shapefile 2, right? Now save it. Choose your geometry type. Which type of geometry you want to create? Point, line, or polygon? So first we will learn how to create a polygon. So I am selecting a polygon feature over here. Then provide your coordinate reference system. As by default, here it is the GCS coordinate systems are there, but you have to change it in projected coordinate system because it is easier. In case of GCS, you can't calculate the area because the unit for GCS is degree minute at second, and for projected coordinate system, you should calculate the area. Now provide the name for this particular shape file. So as I am digitizing the block boundary of Hooghly district, so I am providing a name over here, that block boundary. And the type of data, this type of data you may create text data, whole number, decimal number. So these are the types of data available. But for this particular block boundary, we will use text data and add it. Click on OK. This shape file is now created. Just click on this shape file, and a tool called toggle editing is now highlighted. Just click on the toggle editing option or tools. As you click on the toggle editing tool, so many other options are also getting highlighted. Just click on this particular tool, add polygon feature, and start your digitization. This is a bit time consuming process. It may take some time to digitize very accurately, but I am just showing you in a very
So
coarse manner.
are you clicking your mouse at every few millimeters?
Yeah.
Right.
You just move your mouse and click on the boundary that are visible to you. And if you wrongly make any point, then just click on backspace and remove it like this.
So this is the method by which we create a geometry, okay? That is, we vectorize it or we digitize it. That is converting it from an analog format to a digital format. It should be a left click.
Yeah, it should be a left click. And when you finish your digitization, at the last point, you just make a right click on your mouse. And this type of dialog box will open. Just provide a ID. So for this, I'm providing a ID 1 and name of the block. So for this particular block, although the name is not mentioned, but the name of this particular block is Goghat 2.
Why don't you just mention ABCD? That will be easier from there.
Yes, sir. So I am just writing A for this particular block. Okay.
This block can be known as taluk in different states.
Yeah, taluk or mandal, it may be.
Mandal, huh? In West Bengal, it is known as block.
It is block, community development block, we can say.
Yeah.
So my first block is now getting digitized. In the same way, we can digitize another block.
Sir,
Yes.
sir, while digitizing, if we by mistakenly click the right click in the halfway, then how this
Then you have
whole process you to repeat it?
Yeah.
You have to repeat the whole process. Only just show it. Just show it.
Yes, sir. Suppose I am digitizing this particular block, and now I make a right click on it. Then a dialog box will open, but you have to make the same process, entire process, right?
Just cancel it or click that.
Yeah, I am again showing you. Yeah. So just cancel it, and this digitization will disappear from your screen. But when you digitize two particular block which has a common boundary, so to digitize the common boundary, there is a set of options available you need not to digitize this manually because there is some overlapping problem may occur over here. So to minimize this overlapping problem, you just use a particular tool set called snipping option. So it will be available in project menu. Under project menu, snipping options are available. Okay. So just click on snipping option. And after clicking the snipping option, again a dialog box will open. Just click on this red option or red button, enable snipping, and then provide advanced configuration. Check these two boxes, and now you remove it. So now, whenever I am looking at my cursor, snipping tool are showing that here is a particular set of boundary that I have already digitized. Okay, so I will start from here for this particular block.
Can you please repeat the snipping option?
Yeah, I am repeating. Just complete this process. Yeah. Now you need not to follow this particular boundary because this is a common boundary. Just you click arbitrarily and then make a right click on it, provide ID 2 and named it B, and just click on OK. What happened? Okay.
Well, you should go by that. You should
Yeah.
go by the boundary.
Yes, sir. I am
If the
repeating the
tolerance level
snipping.
is high, if the tolerance level is high, then it will take it. Otherwise, not.
I am just showing you the snapping option. So snapping option is available under project. Under project, snapping option is available. Go to snapping, then click on this particular option, red button, make it advanced configuration, and then check these two boxes, avoid overlap. Yeah. Topological editing should be here.
ঠিক আছে, ঠিক আছে.
Okay. Just move your cursor and make click on the boundary line.
Go according to the boundary.
Yeah, and just make a right click on it.
Click করতে করতে যেতে হবে তো. Only you have not clicked over there.
To
B. Oh, B.
Now, your second block is also digitized. In the same way, you can digitize the third block. But first of all, I will digitize the common boundary. So here in this particular block, the common boundary is this particular boundary is a common boundary. So just make a click over here and then trace it. Yeah. Three and C. Just click on OK. So the third block is also getting digitized. In the same way, you can digitize all the blocks. And during digitization, if you make any mistake or if your digitization boundary is not perfectly aligned with the actual boundary, you may edit it by using the editing vertex option. So just make a click on this particular option, vertex tool, current layer, and now the vertex are showing to you. So you just make a double click on each of the point and shift it according to your requirement, or you may create another vertex in between two vertex. Suppose if I want to create a vertex over here, then just double click and shift it to this particular location. So in this way, you can more accurately digitize your particular set of data. Yeah. So this is the editing tool you can use. So this is the polygon feature that we have created by using polygon vectors or polygon shapefile. Now you have to save it. To save these polygons, you just click on this particular option, save layer edits. Just click on this particular option and your data will automatically saved. If I remove it, or if I remove the background layer, then if I remove this layer and want to import this layer from the layer panel, just click on layer, then add layer. But in this particular case, we have to use add vector layer, not add raster layer, because this is the vector that we have created by using polygon shapefile. So add vector layer, go to your folder or file on which you saved your shapefile. So shapefile 2 is my polygon feature that we have created. Shapefile 2, select it, open, add. Yeah. By clicking on this shapefile 2 polygon, you go to the open attribute table and you may add some data set. For example, if you want to study in which particular block, how many areas are there, how many hospitals are there in a particular block, or what are the health infrastructure available in a particular block, you may add n number of data set by using this attribute table For example, if you want to add a particular table, you just just a minute. Yeah. So first of all, you have to active the edit panel or toggle editing button, and then here the option new field will shown to you. So just click on new field and provide a name, for example, area. Then the area should be in, it may be whole number or decimal number, but I using decimal number. Yes, sir. Yes, sir.
Just go by the same process, otherwise it will be confusing for them. Say, for example, we want to add some point features, say number of hospitals in an area.
Okay, okay, sir. So just like polygon feature, you can generate point features and polygon features. So in this particular map, you can see the green dots or green circle actually represent the groundwater monitoring wells. And there are several roads and networks, railway networks are available. So these are the linear feature. To digitize this linear feature, we will use line shapefile. And to digitize this groundwater monitoring well, we will use point shapefile. So again, in the same way, just go to layer.
Sir, before you go to the next one, if I may ask one doubt. So those digitization, the color that you got, it's purple for all 3 blocks, right?
Yes.
So does the color matter, or is
You
it
can
like
change, you can change this color in a very easiest way. So don't worry. This color is this color has significance. If you want to show different blocks by using different colors, you can do that.
Right, like in a state map, we have different districts in different color, like that.
I will
absolutely.
show you.
This is just the primary condition for vectorization. Okay.
Right.
And say we want to create a map for the population density of the blocks, okay, or the taluks maybe,
Right.
or maybe the different states of India, say for example, and you want to represent them within 5 class intervals, and you can just do it with the help of that. But this is just the primary stage. As we proceed, we'll be showing all these things. Okay.
Okay. Thank you.
Just like I have drawn some polygons, I would like to draw some point features and line features. So in the same way, just go to the layer, create layer option, new shapefile layer. But here, in this particular case, I will use rather point shapefile. I will name it point shapefile. Save it, and geometry type should be point. Again, I have to change this projection system. Now, new field, just named it.
Hospitals.
Yeah, hospitals. Okay. Then add it.
Text type.
Just text data. And okay. Now click on this point shapefile layer, and again go to toggle editing. Click on toggle editing button, and again here add point features options are now highlighted. Just click on add point option layer and start digitization.
You just have to make a left click on each point. Say, for example, all these green dots are hospitals. So go to these green points, just make a left click, the box will appear.
And just provide some IDs. So in this particular case, I'm providing ID 2 and hospital B. Okay. So in the same way, just make a left click, ID 3, hospital C. Yeah. ID 4. In the same way, you can do. Just like this.
Just do it for the 3 blocks, Manoj, which you have digitized.
Yes, sir.
Not necessary to take all the points, but just do it randomly.
Excuse me, sir. Sorry,
Yes.
interrupting you. What if I have the latitude and longitude of the hospitals and I want to mark it using the latitude and longitude and I do not know exactly where it's on the map?
Ma'am, absolutely you can do it. That is the reason why we did the georeferencing. You have both ways option. One is that if it is marked on the map, you can digitize it like the way we are doing it right now. The other option is that if you have the latitudes and longitudes for that particular hospitals, say for example, you live in the state of Maharashtra and you have all the state hospitals latitude and longitudes for that. You take a georeference map of Maharashtra or you take a map of Maharashtra, you georeference it, and then you can import all the GPS data into the map directly.
Sir, if you can demonstrate how to do that?
Yeah, obviously I will do it. But
Okay.
we are in the primary stage. I'll do it.
Okay, thank you.
I'll do it for you.
So
Even in the Google Earth also you can, there is a software which is Google Earth Pro, freely available. I think most of you use it also nowadays. There also you can do it, or if you even don't have to, you even don't have to go to the field for collecting the latitudes and longitudes for the hospitals. You can directly get it from the Google Earth. You can fetch it from there. We'll show you.
Okay, sir, thank you.
Okay, ma'am.
So the point feature for all the 3 blocks that we have digitized earlier as a polygon layer, we have digitized. Now, another feature I would like to digitize, that is the
No, just
linear
show them.
feature.
Just show them. Just
Yes.
show them the point features on the
Yes.
polygon.
So just click on this point shape file option or point shape file layer, make a right click over here and then go to open attribute table. If you go to open attribute table, you may see that these are the IDs, different IDs that I have provided at the time of digitization, and these are the hospital names.
Open it. Open
You-
it. Attribute table is not opened.
Is it visible?
Attribute table I can't see. তুই দেখতে পাচ্ছিস?
হ্যাঁ, আমি দেখতে পাচ্ছি তো স্যার।
Okay, maybe my
Is it
internet.
visible to everyone?
No.
Just go to the point shape file layer, make a right
Do
click
it
over
once
point
again.
shape
We
file,
can't see it, huh?
and then click on open attribute table. Now, in this particular open attribute table, 2 columns are available. One is ID, another one is hospitals. You may add another columns or n number of columns according to your purpose and study. So,
Manoj can't see it.
এরকম কেন হচ্ছে?
So maybe in screen share, you must have shared only the software window. So the second window is not getting shared. So when you share the entire computer screen, then it will show, I think.
Maybe. Manoj, stop sharing and you go for the entire sharing.
Yeah. Actually,
Stop sharing.
I think is it visible right now?
Now it's visible.
So when you
Add field
click
over
on
there
the
and add say a number of beds in the hospital and number of doctors in the hospital.
Yeah.
Make two fields, number of beds and number of hospitals.
So just,
Beds and hospitals.
yeah. So if you want to add some new field, just click on this particular option, new field, and named it number of beds, whole number, integer, and then number of, what's it? Number of, if I add another field like number of patients, it is not taken.
No, they will not take so many. You just do not patients. You just do patients.
Yeah. Patients, number of patients.
And the type should be whole number. You just tell it now why it should be a whole number. And just
So
show.
then, yeah, the type of the patients,
No,
it
you
should
just
be a
go
whole
to
number.
the
Yeah.
drop down. You just go to the drop down.
So it should be whole number for patient. But if you want to calculate the area, or if it maybe other thing, then you can use decimal number, text, whole number, integer. So in this particular case, we will use whole number for patients. And you likewise, you may add another fields according to your purpose.
Do this thing. This is sufficient. I think for that.
So I am just stop sharing this particular window and coming to the main window part.
You add some data, na?
Yes, sir. We can add data over here.
You
Like
add
this.
data and show a bar graph with this.
Like this, yeah. So actually, in the next class, we will show how do we create bar graph, pie graph, or color chart. So we will show it in the next session actually.
Manul.
Yes, sir.
Just add some number of bits and just show a bar graph to them.
Okay, sir.
Just show it. You will tell them how to do it in the next class.
100. Suppose 800. 1150.
Then while adding a new field, there is an option called length. So what does that length mean?
Length is the number of the numericals that you can add. That is, if it is a whole number, then what is the number you can add? Say, for example, for lakhs, we have 5 zeros and 1. That is 6. For crores, we have 7 zeros and 1. That is 8. Like that. But that is okay. Nominal one column is okay.
Yeah. Okay. Save this. What happened?
Start editing courses. What happened? Hello.
Yes, sir.
What happened?
Actually, it is not showing after saving the.
Okay, just to show them the points and the polygons.
1200, 1450, 1500.
কিছু দেখতে পাচ্ছি না কিন্তু
Yes, I'm just showing. So is it visible?
The map is visible.
Okay.
Okay, just show them, show them the point layer with the polygons. Remove the map.
Just I am removing the color. So these are the different blocks, and these are the number of hospitals that are situated in each particular block, each of the block. So if I want to draw some bar graph or pie chart by using this data, you can do it. But in the next class, I will show you how to prepare a bar graph or pie chart. So in the same way, we just create a line feature, like go to the layer panel, create layer.
Excuse me, sir.
Yes, yes, ma'am.
In this, sir, it is save file. Can we see here? We can see the number of hospitals, but we can't see the number of patients here. So, is there
Actually,
anything?
No, ma'am, actually, it's not the number of patients you cannot see over here. It is only the location, isn't it? It is only the location of the hospitals. The number of patients can be shown with the help of some statistical diagrams like a bar graph or a pie chart, like that. Or even we can go for choropleth mapping, that is density mapping.
In one save file, we can particularly visualize the one parameters only.
No, you can visualize at least two by using different diagrams.
And so, sir, actually, I have some. I
Say
have
for
seen
example,
some.
I'm saying you, say for example, how many people are suffering from a disease X, okay?
Hmm.
And how many patients of the same disease are being admitted to your hospital. So you can visualize those two at the same time. You can visualize that, but before that, you have to learn this point feature, polygon feature, and the line feature. These two are being already drawn, polygon and point. Now you have to learn the line feature.
Sir, I have a doubt. But
Okay, again, please tell.
hello.
Please tell.
Sir, actually, here is the number of hospitals is shown in some circles, right?
Right.
But I have seen some other papers, like someone in the triangle, someone in the squares, so that we can visualize other parameters also.
You can do it in any geometrical type you want. Triangle, square, circle, whatever.
That means we can visualize the more than one parameters in a particular sequence.
Ma'am, hospital is a single parameter.
Yes, sir. I want to see the number of beds in that hospital.
Ma'am, that is a separate issue. That is a separate issue. We'll add the data and then we can only do it. See, hospital is a spatial unit, isn't it? Number of beds is a non-spatial unit. Say you can get the address of a hospital. You cannot get the address of number of beds, right? Anything which contains an address is a spatial data. Anything which does not contain an address is a non-spatial data. So these are basically spatial data. Say a location of a school, a location of an ATM, a location of a hospital, the direction of a road, these are spatial data. Now the width of the road, it is not a spatial data, it's a non-spatial data. Or say, for example, the number of patients being admitted in your hospital is a non-spatial data. The type of disease they are having is a non-spatial data. They are not having any kind of address. So primarily what we are doing over here is just locating the entities. After the location, we'll be going for the non-spatial data analysis. Okay, ma'am?
Sir, can you get it? Suppose one hospital is getting a more number of patients, another hospital is getting less number of patients.
Okay.
So can you visualize this from the SAFE file, sir?
Say you can visualize, but you cannot visualize any kind of results. Say, for example, two hospitals are being located side by side. One is getting more patients, another is not getting more patients. You can visualize the data, but you cannot visualize any kind of reasons behind that. Okay.
Excuse me, sir. Can I
Yes,
ask
yes,
a doubt?
please, please, please.
Yeah. So here we have located the points as it was present within the map. Like,
Right,
so if
right.
we're having the location, I mean, the latitude and the longitude is what we know. So how do we actually get these points? Like,
Yeah, you
how
can
to convert those into points? I
you
mean,
can add XY data if you have in your CSV or Excel file. Then just go to the layer, and under add layer, you will have the option add delimited layer, add delimited text layer. So by using this option, you can add. Okay.
okay.
We have that in our schedule, and we'll show you that.
Okay, sir. Thank you.
Say for example, you have been to your hospital tomorrow morning, okay, and you want to locate in that particular map. You just take your mobile, you take the GPS point of that particular area of that particular hospital. You come back home, you just digitize the area where you live, say in a particular block, taluk, state, district, whatever may be, and you want to locate it over there. You can just locate it through it. And say you have been in a visit to the hospitals of your taluk or your block or your district maybe, and say suppose for example you have visited 15 hospitals in a day. You take the GPS coordinates of them, you come back home, you import the data into your laptop, provided you have got the georeference map for you and this digitization. You have to
Oh,
have your map georeference. You just do it once in your life, and you can just, I mean, use that particular data throughout your life.
okay, sir. Thank you.
Okay, thank you, ma'am.
Shall I proceed?
Yes, Manul, please. Actually, the primary work of this GIS is quite robust. It's quite heavy. It seems like that we have been doing such a long thing for what results we don't know. But once you complete the primary work, the rest of the things will be quite easier. Because you have to do the georeferencing, you have to do this digitization or vectorization, whatever you say, but you have to do it. Unless you do this primary thing, you cannot proceed further. Anyway, Manul, please
Now,
continue.
in the same way, you can create line features. Again, we will go to layer, create layer, and new shapefile layer. So again, you have to provide a name. So I am providing a name for line shapefile. And geometry type should be line string. Select the coordinate system. Provide a name called roads and railways. Okay, roads. Add this field and click OK. So if I check the background map, there are several roads in this particular area. So I have to digitize these roads. So major roads are actually shown in red color. So if I digitize, I just click on the line shapefile layer and then toggle editing option. And as you click on toggle editing option, another option will highlight add line feature. So click on add line feature and then start digitization. And the end point, you just make a right click. Like previous, I was done for point data. Provide a road name A, just click OK. And then again, you have to digitize another road like this. Second, B. This is the third road. Three. Likewise, you can digitize all the roads that are available in your area. And save it by using this button, save layer edit. Just uncheck this box, and now your road layer is also digitized. If you want to see this road layer, just right click on this line shape file and go to open attribute table. Now here the ID and roads ABCD are showing. And again, you can add some fields like road length, road width, you can add. Types of road, national highways, state highways, you can add it.
Excuse me, sir.
Yes.
Sir, after doing the line diagram here, we can see the attribute table.
Yeah. Yes, ma'am.
Can we get it in the reverse way? Suppose we have the attribute tables and we want to see the line here.
No, you cannot have the attribute table without digitizing it. The attribute tables are being created after being digitization.
No, sir. Once it is created, there are some making some changes. Can we see it in the shape file or not?
No, you can change it. You can change it, but you have to create it. No? See, the concept is, when we'll just do one thing, you digitize either a road or something like that, anything.
Yeah.
See, ma'am, just look at the concept. I'm just trying to explain the concept. When you do one thing, now you just make these polygons hollow and digitize something within these particular 3 polygons, which are already being digitized.
Okay, sir.
No need to make it hollow. Just move that. Click on the side now to make it invisible. Yeah, just create a layer of create a road layer over here.
Okay.
Not over there. Under the boxes which are already being digitized.
Okay. So I'm removing this part actually.
So, okay.
Yeah. I'm just arbitrarily doing a.
What is that?
Or,
Okay.
yeah.
Do it. You just open the georeference. You just open the georeference layer. Open the georeference layer.
Yeah.
You just এটাকে অফ কর না জিওরেফারেন্সটাকে অন কর পলিগনটাকে অফ কর হ্যাঁ জিওরেফারেন্সটা অন কর যেমন digitize a road over there. Yeah. Okay. Now, ma'am, see, once the road is being digitized, then the computer asks you or the software asks you for the ID and the name of the road. Okay.
Okay, sir.
Are you getting my point, madam?
Yes, sir.
So once you digitize it, then only the software asks you for the details of the road. So once you digitize a polygon, once you digitize a linear stretch, or once you digitize a point layer, then only the software will ask for the details of that layer. Otherwise, it will not ask you. So there is no question of existence of the attribute table without digitization.
Okay, sir.
I will just show them now that the 3 layers. So these are the layers. Okay. These are the layers. So these are basically overlaps. The point layer and the line layer, these are the overlaps on these polygons. So if you understand that how the road goes, what is the distance of the road from the hospital, etc., from this particular image. Okay, one will continue.
Yes, sir. So now by using this data, you can create like if I go to the attribute table of this particular polygon, and if I add some
point layer
হবে না স্যার, পয়েন্ট লেয়ারে করা যাবে না, ওখানে আপনার ব্লক নেম দেওয়া নেই, তো ব্লক গুলো তো করতে
ও
হবে
আচ্ছা
ওর
আচ্ছা।
সাথে। So if I go to the polygon and go to the attribute table of this polygon and then add a field, for example, I am adding a field like area, and the area should be in decimal number.
ওইভাবে
I think you have to reshare the screen again.
Okay, okay, sir.
Also, sir, I have a query, maybe slightly off topic or maybe related.
No,
So
no, sir,
these
please.
these line attributes that we have added,
Yes.
since it is mapped to the real location and real Earth map, right? Is it
Right.
possible to see what the length is in kilometers?
Obviously, you'll just get it. When you just show it in the attribute table.
Yes, sir. I'm just sharing.
So we have to add a field for that, which is named as length. Now the length may be in a whole number, it may be in a decimal number also, but we'll go for decimals, okay?
Right.
Because the length may be 10.5 kilometers, so we'll be going for decimals. And this length over here, see the provider type double. One is length, another is precision. This length is, Manul has given it as 10. That means before the decimals, you can have maximum of 10 digits. And this precision is 3. That is after the point, that is the decimal point, you can have maximum of 3 digits. You can increase it or decrease it as you wish.
But here we are providing the value, right?
No, sir, we have not. No, we will not provide it. We'll get it.
Okay.
For that, we have to install a plugin, I suppose. Geometry. Area total, length. Length. Length with delta.
Just a minute, sir. Actually, the length is showing over here, 42.47.
No, it's an example.
Yeah.
We have to download the plugin, I suppose. It's not getting activated. Because it comes from the geometry, right? Now.
That is the option.
Name it. Decimal.
Yeah.
লেন্থটাকে চেঞ্জ করো, তুই তো অলরেডি লেন্থ লিখে রেখেছিস এক জায়গায়। লেন্থ 1 কর না, এখানে উপরে আউটপুট ফিল্ড নেম।
Yeah.
So
Now
this is your
the
length,
length is visible.
and this is the length in meters.
Okay. Thank you. Great.
This is your length, and this is the length in meters. So that was the reason we did the reprojection. Okay, sir. Manu will
Right, sir.
explain to you that what is the difference between the GCS coordinate, that is just geographic coordinate system, and the projected coordinate system. So this UTM and WGS 84 is a projected coordinate system. So from here we'll be getting the length. So it's the first one for the road A, the length is 63,496.270 meters. That means it's around 63 kilometers.
Right, sir.
Okay, thank you, sir.
Okay, thank you.
So,
One area the polygon.
yeah, yes, sir.
Yes, Miss.
Any problem?
No, sir. Yeah. Go to attribute table. And then, like in the same way, go to the field calculator and make output name area. Yeah. Go to geometry and area. Make a click.
Manu, you can't see anything.
Is it not visible?
No.
I think, is it visible? So in the same way, you just go to the open field calculator in the attribute table, make a field name, output field name. In this case, it is area. Output field type, you have to provide the field type.
You write it. You write it. Area 1, write it.
Area 1.
So it will again be in decimals, okay? Because area cannot be in whole number. It may be in decimals.
Then provide, go to the geometry and click on area. Okay.
Delta area.
Delta area. And then, okay.
So this is the area. 195760276. So this is in meter square. So if I have to convert it into kilometers, that will be equivalent to almost 195 square kilometer for block A. 195.76 square kilometer for block A. The next one is 185.37 square kilometer for block B. And third one is 293.61 square kilometer for block C. So this is the area of the block that we have already digitized.
Sir, can you repeat please that how that you measure the area and length?
Yes.
Sure, Manoj, please do it. Area 2. Just name is that area 2.
Yes, sir. So just go to the attribute table of the polygon layer that you have digitized, and then go to the field calculator option, open field calculator. Just click on open field calculator option, provide output field name like area 2, then output field type, decimal number, then go to the geometry and then delta area. Make a double click over here and click on OK.
Is it okay, sir?
Thank you, sir. Thank you.
Okay.
Okay, sir.
Sir, I have a doubt.
Yeah, please.
Sir, it is helpful only for the geographical location, but in our setup, if we don't know where the cases is rising or where the cases actually they're recovering.
Ma'am, we have not
then
gone to that. We have not gone to that steps till now. These are the primary steps. I mean, calculation of the area, length, point, or location of that are the primary steps. Your question was that from where the disease people are coming.
Sir, where the cases is rising or disease people are rising, or where there is an outbreak of any jaundice or outbreak of any cholera like this. So how can I project this in the system?
Ma'am, for that everything you need to have the data.
Yes, sir.
You have to have the data with yourself. I mean, say there is a cholera occurring in parts of Mumbai, say for example, or say in parts of Kolkata. So you have to have the data that how many persons are suffering from that and what is the area. So see, for doing the holistic work with this respect, once we can digitize, so you have to get a map of that primary, any map, you can just download it from, there are lots of, I mean, portals where from you can download it, maybe the state government portals. So you download a map, you georeference it. I'm just telling you, you georeference it once in your life if you are not being transferred outside your state. So georeference it once in your life for your state, and then on you can just go on adding data. So anyway, if you just georeference the map and say parts of Mumbai, you are walking in Maharashtra, parts of Mumbai, there is a cholera breakup. So you get the area for that particular area. So you digitize that particular area. So once you digitize it, you will get the, the geometry of the area. And then you can add several number of fields for that. When you just add some fields within it.
Yes, sir.
So number of people
So-
suffering from cholera. Okay. So I'm just writing, just add a field named cholera.
Yeah.
CH.
So it is in the whole number.
So it should be now done. So it should be in a whole number, madam.
Yes, sir.
I mean, persons cannot be in a decimal or text. So it should be whole number. So it's a whole number. Just click OK.
And now you can provide the
Say
number of
now there are
members.
3 wards. 3 wards of Mumbai. People are suffering from cholera. Say the name of the wards are ABC. So no one will just allow some figures over there.
Yes, sir. Suppose 150 in the first word.
Yeah.
110 in the second, and lastly the 60. Yeah.
Yeah. Okay, madam. This is clear.
Yes, sir. This is there, but
So
I
these
want
are only the
to
digits.
project it in the layers.
No, this is only the digit. Now see, for a layman, say for example, you are an administrator and a layman has to understand it. Or if, for example, you are a technical person and a person in the administration has to understand which is the block which is suffering from maximum cholera people. So we will just prepare a bar graph for it.
Yes, sir.
Save it.
Yeah. I'm just sharing.
So go to that particular window because this window is showing.
Yes, sir. Diagrams, histograms, cholera, apply. Okay. What happened?
Or the ঠিক আছে
হ্যাঁ
এই স্ট্যাক বার করতো চেঞ্জ করে ওটা ওটা নিচেই ছিল
বাকি লেয়ার গুলোকে টপ করছি zoom to layer and then removing it, apply, not coming.
সিম্বলজি কর
না সিম্বলজি থেকে হবে না বার গ্রাফ size.
Moinul, go to the size. An attribute, choose the attribute from the drop down arrow.
Yes, sir. Yes, sir. Cholera.
Then click on find. And fix the maximum value within 20.
Maximum value 20.
Then click on apply.
20.
Actually, this value depends upon the bar length. Actually.
Bar length. So this is how you ought to understand that which block is having higher number of digits. Madam.
Yes, sir. Sir, got it.
Okay, from the length of the bar, you can understand easily, isn't it? From the length of the bar, you can understand that which block is actually having the higher number of patients.
Excuse me, sir, if I may interrupt. I think we are trying to understand in some maps we have seen, like if you're seeing number of patients, it is shown in different colors for different blocks, like a darker shade for more number of patients and lighter shade for
That can also
less
be
number
done.
of
That can also
patients.
be done. That can also be done. That time kinds of map are known as choropleth maps. Manul, দেখাতে পারবি?
Okay, sir.
Manuel, click on symbology.
Yeah.
Change the single symbol from graduated.
Yes.
And take the value from which the choropleth will be made. From the drop down arrow.
Value.
Then click on classify. And take a color ramp. Then apply.
So what I asked you, select
change the number of class into 2 or 3. Here, from right side, above the advanced section. Right side, classes.
Not coming, sir.
No, sir. Actually,
data might be missing over there. Just let it be. Whatever, let it be. Just click on OK, Manul. No issue. Just click on OK. We are doing it just very roughly. We'll be doing it very properly the next day. So, madam, this was your question, I suppose.
Yes, sir. Yes,
So
sir.
this was, yeah. So you can just project it you can just represent it the way we want it. But the representation is not the problem. The fact is that you have to georeference it, you have to vectorize it, and then you have to feed the data. So once you feed the data, you can do a lot of things. But before proceeding, we have to feed the data for that. And fitting the data need the spatial entity. And for doing the spatial entity, we have to vectorize this. And as being told throughout the class today, that there are basically 3 kinds of vectors. One is the polygon, next is the line, and third one is the points. So these line, points, and polygons need to be fixed. Okay. And then we can proceed on that.
So can I ask about a couple of features for the point?
Sure.
So can we customize the points proportionate to the number of beds or number of patients or something? And also, can we label number of patients or number of beds on the map?
Yes.
Like actual numbers?
Let's see, labeling the patients mean, I don't know, if it is the number of patients or the name of the patients?
Number of patients. So on the map, we can see
the number of patients. See, sir, the number of patients, sir, you have to represent it through something. So bar graph or histogram of the things by which you can represent them.
Right.
Or say,
the
for
point
example, I'm giving you 2 examples. You want to represent the number of patients suffering from malaria in the blocks. Manul, just remove this one. Remove it. So here are 3 blocks, right, sir?
Right.
There are 3 blocks. Say, for example, 3 blocks or 3 wards, whatever you suppose. So if you want to represent the number of patients suffering from that, so the blue bars will be giving you an estimation of it.
No, I was talking about the point shapefile, not the blocks. the hospital that we have
No, sir,
labeled.
just coming to the point,
Right,
yeah.
right.
Now, these are the patients. This was done according to the question of the madam that how many people are suffering from a particular area. Okay, sir.
Right, right.
Now, your question is on the basis of the points. On the
Right.
basis of the points.
And actual numerical like numbers on the map, numbers showing on the map, like
legends can be
23,
given,
35.
sir. Everything will be given. We are just
Right.
on. We have just
Okay,
done 20. Okay, sir.
Okay.
Once we do 70%, 80% of the total exercises, I mean, the things will be much more clear to you.
Okay, sure. Thank you.
But it's already 9 o'clock today. So whatever I would request everybody that please go for the two primary steps. One is georeferencing and the next is vectorization of the map that has been provided by us. Because if you can do it, then only we can proceed it, I mean, in a way which will be helpful for you. Otherwise, it will be of no use. Anyway, Manu, do you need to say anything more? Otherwise, we'll close.
Yes.
And so can you share the recording? I just missed a very small part of the demo where from
Sir, actually, I am not
georeferencing.
supposed to. I am not
Right.
supposed to share that recording.
So if someone can quickly show me the reprojection step, because after georeferencing there was a very quick step for
please show the
reprojection.
reprojection. Please show the, okay, no issue. We'll be showing you the
Yeah,
reprojection.
yeah, I just missed that.
Okay,
60
no issue.
seconds of video. Yeah.
Reprojection is a process by which we convert the three-dimensional surface of the Earth to the two-dimensional surface. So that is the main objective of it. And therefore, all the values, as you also asked, sir, that what is the length of the road. So the values are coming in meters. So until we reproject, we will not be getting the dimensions of it. Dimensions means what is the length, what is the width, what is the area.
Right. Okay.
So this is the actual georeference image in GCS. So if you want to reproject it, then just go to raster and then projection, wrap reproject, provide the input layer that you want to reproject. In this case, Hooghly district modified, and then provide the source CRS, that is EPSG 4326 WGS 84, and target CRS, that means projected CRS, and then provide the output folder name in which you want to save your reprojected file. So I will name it reproject and just click on run. Now your reprojection complete.
Okay. Thank you so much.
Thank you, sir.
Sir,
Sir?
also wish to know if the PPTs would be shared, the ones that you keep showing in between.
So it's okay for today, Manu?
Yes, sir.
Sir, you have just mentioned some websites from where we can download those file maps. So can you
I will
please
show you.
repeat?
It will take time. It will take time. I'll show you. You have to create a user ID, login ID. If it belongs to your particular state, you can go to the government portals and IDs. You can download them. Otherwise, for downloading images, census data, etc., I'll show you. Maybe the day after we'll be completing this vector part. After that, I mean, on the 4th class, we'll be showing you the portals from where you can download the data. Okay.
Sir, I was asking if the
Yes, ma'am.
PPT would be shared.
PPT.
Presentations, of
No, we are not
those
using any
that
PPT.
I mean the kind of thing that you use to explain datum and things.
For data. Okay, I will provide you data for that. I mean, I will provide you some materials for that because only with the diagram we will not be able to gauge anything.
Okay, okay, sir.
I'll provide you journal articles or maybe book chapters from where it will be easier for you to understand. Okay.
Okay.
Or you will get a holistic concept. Otherwise, my PPT is only for my my students maybe, where it consists of only half-hearted diagrams, nothing. I mean, without any kind of background explanation, nothing would be understood.
Okay, sir.
Is it, ma'am? Yeah. Thank you. I'll provide you with that. So the things we are going to provide you are the UTM zones. One will just remember, huh?
Yes, sir.
UTM zones, papers related to datum, and the third one is what I just thought. Oh, we are going to show the details of the portals. So we'll provide you with two things through WhatsApp by the next day. Thank you. I'm leaving.
Okay, sir.
Thank you, sir.
Thank you, sir.
Thank you. Thank you very much. Thank you. Manuel, thank you.
Yes, sir.
Showman, thank you. And thanks everybody. Good night.